Hi, Intro to Calc. This is 5.2, day 3. So I calculate the integral from 0 to 2 of x to the 5 dx, and I get that that's 32/3. So right now you don't have to know how I come up with that. Eventually you will know how to do that. But right now we're just going to kind of play around with the area as we go through these integrals. So this represents the area from 0 to 2. Now x to the 5 is a function that's symmetric about the origin. So I know that in this region right here, I would get the exact same image down here. So that's what we're doing right now, is we're going to play around with the area as we see it unfold. So I know that this chunk is 32/3. All right, number 1, we want the integral from -2 to 0. So that represents this region down here. And because it is below the x-axis, we know that it should have the exact same area except just be negative. Number 2, this time you're integrating all the way from -2 to +2. So here's the -32/3 plus 32/3, and so that should make a change in area of 0. Number 3, you'll have to think about some of the transformations that you guys have done in the past. So when you have a -7 on the inside in Algebra 2 or in pre-calc, you guys would have said that this is moving your function to the right 7. And if you notice, your bounds have also moved to the right 7. The low one was 0 and you added 7 to it, and the high one was 2 and you added 7 to it. So this whole thing looks intimidating, but it's actually the exact same area because the entire function has been shifted to the right 7 units. Number 4, the integral from 0 to 2 of x to the 5 plus 4. You can think about this 2 different ways. I think the easiest way to think about it is to shift this function up 4 units. The parentheses I know look a little weird, but this is the parent, and then you're raising it up 4. So 1, 2, 3, 4, and then you drop it down. So this area here is 32/3, and this space underneath is a rectangle. So we have 32/3 plus 4 times 2, so 32/3 plus 8, and you can just leave your answer like that. So just again as a reminder that when you have your function and then you shift it up, it's not just adding on 4, it's adding on a rectangle that is this tall by this wide. So that's a rectangle with 2 units wide because our integral goes from 0 to 2. Number 5, this time the integral runs from 2 to 2. And so there is no width of any of the rectangles in our function. So this is the curve, but it's saying what is the area at this particular place. And even this highlighter has a thickness that is not visible when you're going from 2 to 2. So I think that this area is perfectly 0. Number 6 is an extension on number 4. So this is doing 2 things. This is both a shift up, and then it's also a reflect across the x-axis. And when you think of that in terms of areas, you really can break it apart. So this is the same thing as the integral from 0 to 2 of 3 dx minus the integral of 0 to 2 of x to the 5 dx. So this is similar to what we did yesterday, that this is a rectangle, 3 times 2 is 6, and this represents the 32/3. Done. Number 7, the absolute value of x to the 5 is going to flip our entire function. Sorry, that doesn't look totally symmetric. Like this. And now you're running the integral from -2 to 2. So that should be double the area, so 64/3. Number 8 is a horizontal shrink by a factor of 1/2. And I know that looks weird because it's a 2x, but again, think back to what you guys did in Algebra 2 and in Pre-Calc, that all of the horizontal transformations have to be the reverse operation. So it is multiply here, which means all of these x values have to be half as big. And if you notice, your bounds are also half what they were. And so because of that, this is changing our area in only one dimension. I know it feels like you're seeing it twice, but it's actually only changing the one dimension. It's changing the horizontal dimension. Therefore, your area will be 1/2 times 32/3, or 16/3. Number 9, this is a horizontal stretch by a factor of 3. And if you notice, your bounds are also they also changed because again, you're working a transformation in one direction. So you're taking your x coordinates and multiplying them by 3. And so you're just seeing it visibly here that 0 times 3 is 0 and 2 times 3 is 6. So your previous area multiplies by 3. And so your final answer there is 32. Skip 10. And your homework is going to be to do these questions related to sine. I've already graphed it for you, and I already graphed or put in the area from 0 to pi. And you can work through these questions, so all the way up to 23. And I will look in your binder to see your answers and give you credit for homework. Bye.